order food from Swiggy or Zomato. The moment you click place order, many things happens in the background. The restaurant gets your order, the payment system confirms the transaction, a delivery partner gets assigned, you start seeing live updates, and the analytics system records your activity. Now imagine if the order service had to directly talk to payment, delivery, notification, inventory, and analytics systems one by one. If one service is slow, the whole flow gets delayed. If one service fails, the process can break. And during peak traffic, this becomes very difficult to manage. So modern applications need a better way to handle real-time events. That is where Apache Kafka comes in. So, Apache Kafka is a real-time event streaming platform that helps different applications communicate with each other at larger scale. So before we deep dive into the magic of Kafka, let's first see what all we are going to cover in this video. So first of all, we will cover the fundamentals of Apache Kafka and understand why it is used in modern applications. Then we will look at the real-world problem Kafka really solves, especially when multiple systems need to communicate in real time. After that, we will understand what Apache Kafka is using a simple real-life example. Then, we will break down Kafka architecture and learn important components like procedures, topics, consumers, brokers, and clusters. Next, we will understand partitions and offsets. Then we will cover consumer groups and see how multiple consumers can work together to process data faster. After that, we will understand how Kafka works step by step, from producing an event to consuming it. Then we will explore real-time processing with Kafka Streams and how Kafka helps businesses react instantly to the live data. Next, we will clear an important beginner question, that is Kafka a replacement for a database? And finally, we will compare Kafka with traditional messaging system and understand where Kafka is used in real-world applications. So, by the end of this video, you will have a complete understanding of Kafka course. Also, here's a quick information. If you want to build a strong career in cloud, DevOps, and real-time data systems, then check out Simplilearn's AI-powered cloud computing and DevOps certification program. This program is offered in collaboration with IITM Parvatak and helps you learn cloud and DevOps across AWS, Azure, and Google Cloud. You will explore important concepts like CI/CD, Docker, Kubernetes, Terraform, monitoring, microservices, and cloud deployment. The course also includes hands-on labs and real-world projects, including real-time data management using tools like Kafka. You also get live interaction learning, self-paced content, and masterclasses by IITM Parvatak faculty. Along with technical skills, the program offers AI-powered job assistance, resume support, LinkedIn optimization, and mock interviews. So, if you want to understand how modern cloud native and DevOps systems are built and managed, this program can be a great next step. Do check out the link in the description box and in the pinned comments for more details. So before we start, here's a quick quiz question for you. And the question is, what is the main purpose of Apache Kafka? And your options are option A, to design website pages, option B, to store images and videos, option C, to stream real-time events, or the option D, to replace all the databases. Let me know your answers in the comment section below and let's see who will give the right answer first. So without any further ado, let's get started. So before understanding Kafka, let's understand the problem it solves. Suppose you are building an e-commerce application. When user places an order, many systems need the same order information. The inventory stock needs to reduce the stock, the payment system needs to verify the payment, the delivery system needs to arrange the shipment, the email system needs to send the confirmation, and the analytics systems need to record user behavior. One simple way is to make the order service directly call all these systems. But this creates a problem. If one service is slow, the order process may get delayed. If one service is down, the order flow may face errors. And if more services are added later, the system becomes harder to manage. This is called tight coupling, where every system depends too much on every other system. And Kafka helps solve this problem. Instead of directly talking to every service, the order service simply sends one event to Kafka, order placed. Kafka stores that event. The other services can read it whenever they need. The inventory service can update stock, the payment service can verify payment, the notification service can send the confirmation. And then the analytics service can record that activity. So the order service does not need to manage all these systems directly. It simply publishes the event and the Kafka handles the communication. That is the basic problem Kafka really solves. So now, once the basic idea is clear, let's understand what Apache Kafka really is. So Apache Kafka is a distributed event streaming platform. That sounds technical. So let's make it simple. Kafka is a system that helps applications send, store, and process real-time data. One application sends data to Kafka. Kafka stores that data. Other applications read that data from Kafka. The application sending the data is called producer. The application reading the data is called consumer. And the place where Kafka stores messages is called a topic. In simple words, Kafka is a middle layer that helps different applications exchange real-time data without directly depending upon each other. The data is sent to Kafka is usually called an event. And an event means something happened. For example, a user logged in. An order was placed, a payment was completed, a product was added to the cart, a delivery status was updated, a server generated an error log. So Kafka is useful when these events are happening continuously and multiple systems need to process them. That is why Kafka is used in food delivery apps, banking systems, e-commerce platforms, telecom systems, streaming platforms, and real-time analytics systems. Now let's understand Kafka with a simple newspaper example. Imagine there are many reporters. These reporters write news articles every day, but they do not personally deliver every article to every reader. Instead, they publish articles in a newspaper. Readers then read the newspaper based on their interest. So in this examples, reporters are like producers. The newspaper is like Kafka topic. The readers are like consumers. The Kafka is the system that manages publishing and reading. The producer publishes the data. Kafka stores it inside a topic. Consumers read the data from that topic. That is the core idea of Kafka. Now, let's understand the main components of Kafka. The most important Kafka terms are producer, topic, consumer, broker, cluster, partition, offset, and consumer group. These terms may sound technical at first, but they are actually very simple. And let's understand them one by one. So, a producer in Kafka is an application that sends data to Kafka. For example, in a food delivery app, the order service can be a producer. When a customer places an order, the order service creates an event called order placed. Then it sends this event to Kafka. A producer can send many types of data details like order details, payment details, user activity, location updates, service logs, and click events. So the job of a producer is simple. Create data and send it to Kafka. That's it. Now let's understand another important concept of Kafka, that is topic. So a topic is like a category where messages are stored. For example, we can have topics like orders, payments, deliveries, user clicks, and server logs. So if the order service sends order data, it can send it to the orders topic. If the payment service sends payment data, it can send it to the payments topic. So a topic helps Kafka organize messages. Think of a topic like a YouTube channel. If you subscribe to the tech channel, you get tech-related videos. If you subscribe to a cooking channel, you get cooking videos. Similarly, consumers read messages from the topic they are interested in. Now let's understand what a consumer is in Kafka. So a consumer is an application that reads data from Kafka. For example, once an order event is sent to the orders topic, many consumers can read it. The inventory service can read it and reduce stock. The delivery service can read it and start the shipment. The important point is this: a producer does not need to know who are the consumers of the data, and Kafka allows multiple consumers to read that data independently. This makes the system flexible, scalable, and easier to maintain. So now let's understand broker and cluster in Kafka. A Kafka broker is a server that stores data and handles requests. Kafka usually runs on multiple servers. Each server is called a broker. A group of brokers is called a Kafka cluster. For example, a company may have 3 Kafka brokers: broker 1, broker 2, and broker 3. Together, they form a Kafka cluster. Now, you must be thinking, why do we need multiple brokers? Because Kafka is designed for large-scale systems. If one broker gets too much traffic, other broker can help. If one broker fails, then Kafka can still continue working. This makes Kafka scalable and reliable. Now let's understand partitions in Kafka. So a topic can be divided into smaller parts called partitions. For example, the orders topic can have 3 partitions: orders partition 0, orders partition 1, and orders partition 2. Why do we need partition is because partitions help Kafka handle large amount of data faster. Imagine a supermarket with only one billing counter. If hundreds of people are waiting, the line becomes slow. But if there are 5 billing counters, more people can be served at the same time, right? So partitions work in a similar way. They divide the data so Kafka can read and write messages in parallel. This is one of the reasons Kafka is so fast. Now let's understand offset in Kafka. An offset is a position number of a message inside a partition. For example, if messages are coming into a partition, the first message gets offset 0, the second message gets offset 1, the third message gets offset 2, and so on. So offset helps Kafka identify the exact position of each message. It also helps consumers track what they have already read. For example, if a consumer has read messages up to offset 10, it knows that the next message to read is offset 11. So, offset is like a bookmark. It tells the consumer, you have already read up to this point. If the consumer stops or crashes, it can restart from the correct position. Now, another important concept, that is consumer group. A consumer group in Kafka is a group of consumers working together. Suppose the orders topic has 3 partitions. If only one consumer reads all the data, processing may become slow, right? So, we can create 3 consumers in the same consumer group. As consumer 1 reads partition 0, consumer 2 reads partition 1, and consumer 3 reads partition 2. Now the work is divided. This helps in parallel processing. Consumer groups are very useful when traffic increases. For example, during a big sale, if order traffic increases, we can add more consumers to process messages faster. Now let's connect everything together. Here's how Kafka actually works. Step 1. A producer creates an event. For example, user placed an order. Step 2. The producer sends this event to the Kafka topic. For example, orders. Step 3. Kafka stores the event inside a partition of that topic. Step 4. Kafka assigns an offset to the message. Step 5. One or more consumers read the message. And then the step 6. Each consumer processes the message for its own purpose. For example, inventory service updates stocks, payment service verify payments, email service sends confirmation, delivery service starts shipment, and analytical service stores the event. The best part is that all these systems can work independently. If the email service is down for some time, Kafka can still keep the messages. When the email service comes back, it can continue reading from where it has stopped. That is the real power of Kafka. Now let's understand real-time processing with Kafka Streams. Now, Kafka is not only used to move messages from one system to another. Kafka can also help process data in real time. This is called stream processing. Stream processing means processing data while it is still moving. Instead of waiting for data to be stored first and analyzed later, stream processing allows system to react immediately. Let's take an example to understand this. Let's suppose a food delivery app is receiving thousands of orders events every minute. Kafka can stream these events in real time. Now, different systems can process these events instantly. The analytical system can count how many orders are coming every minute. The fraud detection system can check suspicious payments immediately. The delivery system can track live order status. The dashboard can show real-time business numbers. So instead of waiting until the end of the day to analyze data, Kafka helps businesses take action immediately. So a simple way to remember it is like this. Kafka Streams helps process data as it arrives. For example, order placed, it goes to Kafka, it processes instantly and update dashboard. So, Kafka is not just about sending and receiving messages. It is also about handling continuous data streams in real time. Now answering the most common question being asked. Can Kafka replace a database? And the answer is no. A database stores business data like customer details, order amount, payment status, delivery address, and final order status. Kafka stores and moves events like order placed, payment completed, stock updated, delivery assigned, and order delivered. So the simple difference is this. A database stores the current state while Kafka streams the events that change that state. For example, a database may show order status delivered, but Kafka comes with the journey behind it. Order placed, payment completed, delivery assigned, order delivered. So, Kafka and databases work together. A database is like a record book, while Kafka is like live update channel. So no, Kafka is not the replacement for databases. Now you might be thinking, is Kafka just a messaging system? So, not exactly. Traditional messaging system usually focuses on sending messages from one application to another, while Kafka is different because it stores streams of events and allows multiple consumers to read those events independently. Kafka does not just pass messages, it keeps messages for a certain time based on retention settings. That means consumers can come later and still read the old messages. This makes Kafka useful for event-driven systems, real-time analytics, data pipelines, and microservices communication. Now, once the basic idea is clear, let's understand where we can use Kafka in real-world systems. So, one common use case is real-time analytics. For example, an e-commerce company can track user clicks, searches, cart additions, and purchases in real time. Another use case is log aggregation. Large companies collect logs from thousands of servers and send them to Kafka for monitoring. Kafka is also used in fraud detection. Banks can process transaction events in real time and detect suspicious activity quickly. Kafka is used in data pipelines. Data can move from applications to databases, data warehouse, and data lakes. Last but not the least, Kafka is also used in microservices architecture. different services can communicate through events instead of direct API calls. So, whenever there is a continuous real-time data movement, Kafka can be really useful. So now that brings us to the end of this tutorial. So before wrapping, let's quickly revise what we have learned. So Kafka is a real-time event streaming platform. A producer sends the data to Kafka. Kafka stores the data inside topics. The topics are divided into partitions. Each message inside a partition has an offset. A broker is a Kafka server. Multiple brokers together form a Kafka cluster. A consumer reads data from Kafka. A consumer group allows multiple consumers to work together. Kafka can also process real-time data streams, which help businesses react immediately when events happen. Kafka is not a replacement for a database. Kafka moves real-time events while the database stores the final business data. The simplest way to remember Kafka is this. Kafka is a middle layer that helps applications send, store, process, and receive real-time data without directly depending on each other. So, if you're just starting out, do not try to memorize every technical detail in one day. Just remember the basic story. Applications create events. Kafka stores and streams those events. Other applications read and process those events. Once this idea is clear, terms like producer, consumer, topic, broker, partition, offset, and consumer group become much more easier to understand. Kafka may look complex in the beginning, but at its core, it solves a very simple problem. How do we move huge amount of data between systems in real time without slowing everything down? And now you know the answer. That answer is Apache Kafka. So that brings us to the end of our today's video. If you found this video helpful, make sure to like the video, subscribe to the channel, and share it with someone who is learning backend development, data engineering, or system design. Thanks for watching, and I'll see you in the next one.